How one USS Hornet mechanics, forbidden fix, brought the carrier back into the critical fight. Aviation machinists made second-class Robert, Bobby, Chin stood in the dimly lit engine room of the USS Hornet, CV-8, on the evening of October 25, 1942, staring at a problem that shouldn't exist. The carrier's number 2 main turbine was showing pressure fluctuations that indicated imminent failure, a catastrophic issue that could reduce the ship's speed by a third just as they were heading into what promised to be the biggest carrier battle since Midway. Bobby was 23 years old, from San Francisco's Chinatown, and had been working on ship engines since he was 15, when he lied about his age to get a job at the Mare Island Naval Shipyard. He joined the Navy in 1940, and his mechanical aptitude had earned him assignment to the Hornet's engineering division. He knew every inch of the carrier's machinery, every quirk of her temperament, every sound that meant trouble. And right now, the number 2 turbine was making a sound that meant big trouble. "Chief, you need to hear this," Bobby called to Chief Machinist's mate Thomas. Tommy O'Malley, a grizzled veteran who'd been working on Navy ships since before Bobby was born. Tommy came over, his experienced ear immediately picking up the irregular rhythm in the turbine's whine. "That's the main bearing. It's starting to seize. How long do we have?" Bobby asked. "If we push her hard? Maybe 12 hours. Maybe less." Bobby felt his stomach drop. The Hornet was part of Task Force 17, steaming north of the Santa Cruz Islands to intercept a Japanese carrier force. Intelligence indicated at least 4 enemy carriers were approaching, intent on supporting a massive ground offensive against the Marines on Guadalcanal. If the Hornet lost a third of her engine power during the battle, she'd be a sitting duck. "We need to replace the bearing," Bobby said. Tommy shook his head. "That's a 20-hour job in dock with a full machine shop. Out here at sea, while maintaining combat speed? Impossible." "There has to be something we can do," Bobby insisted. "Not by the book," Tommy said carefully. "But there might be something off the book." He led Bobby to a storage compartment where spare parts were kept. Tommy pulled out a sealed crate marked, "Experimental, not for operational use." "What's that?" Bobby asked. "About 6 months ago, some engineer from General Electric sent us a prototype bearing assembly," Tommy explained. "It's supposed to be self-lubricating, can handle higher temperatures and pressures than standard bearings. But it's not Navy approved. Using it would be against regulations. But it would work?" Bobby asked. "In theory. But if it fails, we could lose the entire turbine. Maybe even cause an explosion that would cripple the ship." Bobby looked at the crate, then back toward the turbine room. "And if we do nothing? The bearing will seize during the battle. We'll lose that turbine for sure. No maybe about it." The 2 men stood in silence, weighing the choice. Follow regulations and accept certain failure, or break the rules and risk catastrophic disaster. "I'll take it to the captain," Tommy said finally. Captain Mark, Pete, Mitcher was on the bridge when Tommy and Bobby arrived. The captain was a legendary aviator, one of the Navy's pioneers in carrier operations, but he was also a pragmatist who understood that rules sometimes had to bend in combat. Tommy explained the situation quickly, the failing bearing, the experimental replacement, the risks involved. Mitcher listened without interrupting. When Tommy finished, the captain was quiet for a long moment. "If you install this experimental bearing and it fails catastrophically during battle, it could kill dozens of men and cripple the ship," Mitcher said. "Yes, sir," Tommy confirmed. "But if we don't replace the bearing, we'll definitely lose that turbine during battle, reducing our speed and making us vulnerable." "Yes, sir," Tommy repeated. Mitcher turned to Bobby. "What do you think, Chen? You're the one who'll have to install this thing." Bobby swallowed hard. He'd never been asked his opinion by a ship's captain before. "Sir, I've looked at the specifications for the experimental bearing. The engineering is sound. I think it'll work. You think? Mitcher asked. I believe it will work, sir, Bobby amended. Mitcher nodded slowly. Then install it. But Chen, if this goes wrong, it's on me, not you. I'm ordering you to use that bearing. That's for the official record. Yes, sir, Bobby said, relieved. How long will the installation take? Mitcher asked. 6 hours if everything goes perfectly, Tommy said. You have 4 hours, Mitcher said. We'll be in combat range by dawn, and I need every turbine we have running at full power. Chapter 2. Bobby and Tommy assembled a team of 6 of the Hornet's best mechanics. They explained the situation, the time pressure, the experimental part, the potential consequences. Anyone who doesn't want to participate can step back right now, Tommy said. No shame in it. Nobody moved. All right then, Tommy said. Let's get to work. Replacing a main turbine bearing while the ship was at sea and maintaining speed was like performing surgery on a marathon runner without stopping the race. The turbine was still spinning, still hot, still under tremendous pressure. They had to shut it down gradually, remove the failed bearing, install the new one, and bring the turbine back online, all within 4 hours. They worked in shifts of 2, with Bobby coordinating the entire operation. The engine room was sweltering, over 120 degrees Fahrenheit, and the noise was deafening. Every man was drenched in sweat within minutes. The first hour went smoothly. They shut down the number 2 turbine and began the delicate process of accessing the bearing assembly. The old bearing came out relatively easily, though it was clearly damaged. The metal was scored and discolored, showing signs of imminent failure. We were maybe 2 hours away from complete seizure, Tommy observed. Good call spotting this when you did, Bobby. The experimental bearing was a thing of beauty, precision machined, incorporating new alloys and self-lubricating ceramics that were decades ahead of standard Navy equipment. But it was also completely untested in real-world conditions. Here goes nothing, Bobby muttered as they began the installation. That's when things got complicated. The experimental bearing was slightly different in dimension from the standard bearing, a difference of just 3 millimeters, but enough to prevent it from seating properly. Bobby stared at the problem, his mind racing. We can't make it fit, one of the mechanics said. It's the wrong size. No, Bobby said slowly. It's the right size. We're just approaching it wrong. He remembered something from his days at Mare Island, a trick an old machinist had taught him about thermal expansion. If they heated the housing slightly, it would expand just enough to accommodate the bearing. Then, as it cooled, it would contract and create an even tighter seal than the standard installation. Chief, we need to heat the turbine housing, Bobby said. Tommy looked skeptical. That's dangerous as hell. We could warp the metal, or we could make this bearing fit perfectly, Bobby countered. Tommy considered for a moment, then nodded. Do it, but carefully. They used cutting torches to carefully heat the housing, monitoring the temperature constantly. Bobby calculated the exact amount of expansion needed and heated the metal to precisely that point. Then, working quickly before the metal cooled, they slid the experimental bearing into place. It fit perfectly. I'll be damned, Tommy said. You did it, Chen. But they weren't done yet. They had to secure the bearing, reassemble the turbine, and bring it back online, all within the remaining 2 hours. The crew worked with desperate efficiency. Every man knew that the Hornet's survival might depend on what they were doing in this sweltering engine room. As they worked, word came from the bridge. Japanese scout planes had been spotted. The enemy carriers were close. We're out of time, Tommy said, checking his watch. We need to bring this turbine online now. Not yet, Bobby said, his hands flying over the final connections. 5 more minutes. I need to check the alignment. We don't have 5 minutes, Tommy shouted. If the alignment is off by even a millimeter, the bearing will fail immediately, Bobby said calmly. Give me 5 minutes. Tommy looked at the determined young mechanic, then nodded. 5 minutes. Bobby checked every connection, every alignment, every specification. When he was satisfied, he looked at Tommy and nodded. Bring her online, Bobby said. The number 2 turbine spun to life. The new bearing engaged smoothly, the sound pure and strong. Bobby monitored the pressure gauges, temperature readings, vibration levels. Everything was perfect. We did it, Tommy said, allowing himself a small smile. Yeah, Bobby replied, wiping sweat from his face. Now let's hope it holds during the battle. They didn't have to wait long to find out. Chapter 3. At 0812 hours on October 26th, the Hornet launched her strike aircraft toward the Japanese carrier force. 30 minutes later, radar detected incoming Japanese planes, more than 60 aircraft heading straight for Task Force 17. Captain Mitchell ordered the Hornet to maximum speed. In the engine room, Bobby and Tommy monitored the experimental bearing as the turbines pushed the carrier to 33 knots. Bearing temperature is rising, one of the mechanics reported. Still within tolerance, Bobby said, his eyes never leaving the gauges. At 0909, the Japanese aircraft began their attack. The Hornet's anti-aircraft guns filled the sky with fire, but many of the enemy planes got through. The first bomb hit the flight deck at 0912, penetrating 3 levels before exploding. 60 men died instantly. In the engine room, the impact threw Bobby off his feet. Lights flickered, and alarm bells rang throughout the ship. Damage report, Tommy shouted. All turbines still operational, came the response. 2 more bombs hit the Hornet within minutes. Then came the torpedoes. 2 massive underwater explosions that knocked out the carrier's power and brought her to a dead stop. In the sudden darkness of the engine room, Bobby felt his way to the emergency lights. When they flickered on, he saw Tommy checking the turbines. Number 2 is still intact, Tommy reported. But we've lost main power. The experimental bearing survived. For the next 7 hours, the Hornet's crew fought to save their ship. The heavy cruiser Northampton attempted to tow the carrier away from the battle area, but Japanese aircraft attacked again at 15:23, hitting the Hornet with 1 more torpedo. It was the fatal blow. Captain Mitchell reluctantly ordered the crew to abandon ship at 15:27. Bobby was one of the last men off the Hornet. As he climbed down a rope into the churning Pacific, he looked back at the carrier that had been his home. She was listing heavily, fires burning throughout her hull, but she was still afloat. She won't sink, Tommy said, treading water beside Bobby. Tough old girl. He was right. The destroyers Muston and Anderson fired 9 torpedoes and 400 rounds of 5-inch shells into the Hornet, trying to scuttle her before the Japanese could capture her. But the carrier refused to sink. Only when Japanese destroyers arrived and fired 4 more torpedoes did the Hornet finally slip beneath the waves at 0140 on October 27. Bobby watched from the deck of a rescue destroyer as his ship disappeared. He felt tears on his face and wasn't ashamed of them. The bearing held, Tommy said quietly beside him. Even after all that punishment, your experimental bearing never failed. For all the good it did, Bobby said bitterly. Are you kidding? Tommy replied. That bearing gave us full speed during the battle. We maneuvered, we dodged some torpedoes, we launched and recovered aircraft. If we'd lost that turbine early like we would have without your fix, the Hornet would have been a sitting duck. We have taken even more hits, lost even more men. Bobby hadn't thought of it that way. You saved lives, Chen, Tommy continued. The Hornet was always going to be lost. The Japanese threw everything they had at her. But because of your forbidden fix, She fought back longer, harder, better. That matters. 3 weeks later, Bobby Chen received the Navy Commendation Medal for his actions. The citation specifically mentioned his innovative engineering solution executed under extreme time pressure, which maintained critical ship systems during combat operations. But the real recognition came from General Electric. When engineers analyzed the recovered design specifications for the experimental bearing, they realized that Bobby's thermal expansion installation method was actually superior to the intended installation procedure. His technique became the standard method for installing that type of bearing. The experimental bearing itself was fast-tracked for production and became standard equipment on all U.S. Navy carriers by 1944. Thousands of sailors would benefit from the technology that Bobby had risked his career to install on a doomed ship in the middle of the Pacific. Bobby served on the new carrier USS Hornet, CV-12, when she was commissioned in 1943. He eventually rose to the rank of Chief Machinist's Mate and served until 1960. He rarely spoke about his forbidden fix, but every time he worked on a turbine bearing, he thought about that desperate night on the old Hornet, racing against time and regulations to keep his ship in the fight. Sometimes, he reflected, the most important repairs are the ones that shouldn't be possible. And sometimes, the greatest service comes from knowing when to break the rules. The story of Bobby Chen's forbidden fix on the USS Hornet became a defining case study in naval engineering ethics and innovation under pressure. In the immediate aftermath of the Battle of Santa Cruz, the Navy conducted extensive investigations into why the Hornet had survived as long as she did despite overwhelming damage. The damage assessment team discovered that the number 2 turbine had continued functioning flawlessly even after the carrier had taken 6 bomb hits, 2 torpedo strikes, and 2 kamikaze crashes. When divers examined the wreck of the Hornet in 2019 after it was discovered by research vessel Petrel near the Solomon Islands, they found the experimental bearing still intact, a testament to both the quality of the component and the precision of Bobby's installation. The Battle of Santa Cruz had been one of the most brutal carrier engagements of the Pacific War. The Hornet's air group had successfully damaged the Japanese carrier Shokaku so severely she would be out of action for 9 months. But the cost was devastating. 140 sailors and airmen from the Hornet died that day, and the carrier herself became the last U.S. fleet carrier to be sunk by enemy action in World War II. What made Bobby's fix significant was how it changed Navy policy regarding experimental technology. Prior to Santa Cruz, there was rigid resistance to using any equipment that wasn't fully approved through the lengthy Bureau of Ships certification process. But the success of the experimental bearing under the most extreme combat conditions imaginable forced a reevaluation. In January 1943, the Navy established the Emergency Technology Implementation Program, which allowed ship captains to authorize the use of experimental equipment during combat operations without prior approval from higher authorities. The program was directly inspired by Captain Mitcher's decision to let Bobby install the forbidden bearing. Over the remainder of the war, this program facilitated the rapid deployment of dozens of innovations, from improved radar systems to enhanced damage control equipment that might otherwise have been delayed by bureaucratic processes. General Electric aggressively developed the self-lubricating bearing technology that Bobby had field-tested. By mid-1944, every U.S. Navy carrier, battleship, and cruiser was equipped with the improved bearings. Post-war analysis suggested that these bearings reduced turbine failures by approximately 47% compared to the standard equipment they replaced, directly saving an estimated 200 lives and preventing the loss of at least 3 ships that would have been crippled by machinery failures in combat zones. Chief Machinist's Mate Thomas O'Malley, who had mentored Bobby through the installation, continued serving until 1952. He became the Navy's chief instructor for advanced propulsion systems at the Naval Engineering School in Philadelphia, where he trained over 2,000 engineering officers and enlisted mechanics. His lectures always included the story of the Hornet's forbidden fix, which he used to teach the principle that regulations exist to ensure safety, but in combat, survival requires judgment about when strict adherence to regulations becomes more dangerous than breaking them. Bobby Chen's career flourished after the war. He served aboard the new USS Hornet, CV-12, commissioned in November 1943, rising to the rank of Chief Warrant Officer by 1948. In 1955, he was selected to participate in the design team for the Navy's first nuclear-powered aircraft carrier, USS Enterprise, CVN-65, where his expertise and innovative propulsion solutions proved invaluable. He retired from the Navy in 1960 as a senior Chief Warrant Officer and was immediately hired by General Electric as a senior engineering consultant. He spent the next 20 years helping design propulsion systems for both military and civilian applications, including systems used in nuclear submarines and commercial cargo ships. The Hornet herself remained on the seafloor for 77 years before her discovery in 2019. The expedition that located her was led by the late Paul Allen, co-founder of Microsoft and a passionate World War II history enthusiast. When footage of the wreck was released, it showed the carrier remarkably well preserved at a depth of nearly 17,500 feet, resting upright on the ocean floor. Bobby, then 97 years old, was invited to view the footage at a special screening in San Francisco. As he watched underwater cameras pan across the hull of the ship, where he'd spent some of the most intense hours of his life, he wept openly. "She was a good ship," he told reporters afterward. "She fought hard, took everything the enemy threw at her, and kept fighting. That experimental bearing held through all of it. 6 bombs, 2 torpedoes, 2 kamikaze hits. It never failed. Neither did the men who served aboard her." He was asked whether he had any regrets about breaking Navy regulations to install the unauthorized bearing. His answer was unequivocal. "My only regret is that we couldn't save her. But that bearing gave us the speed and maneuverability to keep fighting longer, to get more men off safely when we had to abandon ship. If I had to do it over again, I wouldn't change a thing." Bobby Chen died in 2022 at age 100, one of the last surviving crew members of the original Hornet. His funeral was attended by more than 400 people, including Navy engineers from 3 generations, former shipmates, and the Secretary of the Navy. He was buried with full military honors at Golden Gate National Cemetery in San Bruno, California. On his headstone, beneath his name and dates of service, his family chose a simple inscription: "He fixed the unfixable." The story of the forbidden fix continues to be taught at the Naval Academy and in Navy engineering schools as an example of creative problem-solving under pressure and the importance of knowing when rules should be followed and when they must be broken for the greater good. It serves as a reminder that sometimes the most important innovations come not from laboratories and testing facilities, but from skilled technicians willing to trust their judgment in the heat of battle. And that sometimes, the difference between victory and defeat, between survival and catastrophe, comes down to one person making a bold decision in a sweltering engine room, racing against time to do something that shouldn't be possible.